Welcome to the 3D Avatar Builder tutorial series part 6. In this episode, we will add camera controls to adjust camera position based on what we want to edit, add a photo booth mode to see our avatar in action with different poses and take screenshots. For obvious reasons, we have generated all the thumbnails and imported the different assets off screen. If you want to know the secret I used to do it, I delegated it to my dear team member Ami. Thanks to her. We now have all the assets and good-looking thumbnails, but we have a few issues. Currently, nothing is displayed anymore, and we have a crash. This is because if I drag and drop the latest eyes, they now contain morph targets to be able to close and open the eyes to make blinking animations that we will do later, and that you will be able to use on the final avatar. What we need to do to fix it is to add the morph target dictionary and influences to the skin mesh we create. We create the skin mesh in the asset. After adding the geometry, the material, we add the morph target directory and we assign it to the one in the child. If there is none, it will be undefined, so no problem. And same for the morph target influences. And now where we create our skin mesh, here, we simply assign those variables. We save, we pray and reload, and it's working correctly. We now have a lot of good looking assets. Let's try different hair, add a lovely hat, and we now have more options to make our avatar unique. But currently, if we go to the eyes, it's not very visible. So let's enhance again the boxes here. Let's head to UI, search .map. This is where we have all our boxes. Let's get rid of the default color because we will change it when it's selected or not. We change it once selected and in the normal state. We go up and do the same on the remove button. We remove here, we change it here and here. Now it's a bit more visible when we select one of the different assets. Now to make the editing experience better, what we will want to do is when we change the category, for example head, we will want to zoom in front of the face. When we go to the top, we'll go to zoom out and see most of the body and the top. So it will work for both the normal top and also the complete outfit to always have the perfect position for the camera. To do this, we have multiple solutions. We could go to experience, animate our orbit controls or animate the camera directly. But instead, we will create a new component that we will name Camera Manager. Camera Manager. Inside, for the moment, we will just replace it with our orbit controls. Now in the experience, instead of using orbit controls, we can use Camera Manager. That will be in charge of moving that camera. But instead of using the classic orbit controls, we will use the camera controls library. It's directly included in Dry library, and it offers us a lot of methods to animate simply the camera. The documentation is very well written and you have all the explanations. So let's go to methods. And the one that we will use is setLookAt. It takes the starting position where the camera is, the target, so where it's looking at, and enable transition to smoothly go to that position and to look at that new target. Let's start by replacing orbit controls with camera controls. So you can see we have 3 stdlib or dry. Let's take the dry one. To be able to call methods on it, we need a reference to it. Name it controls. Import it. And so far, it should behave like the orbit controls because the parameters we are using, the min, max, polar and azimuth angle, are the same on camera and orbit controls. First, let's get rid of min and max azimuth angle because we want to be able to see the back of our avatar, to see it everywhere. We keep it on top and bottom to not go below the floor or too much high. We can also adjust how far user can go and how close they can go. We don't want to have those cases. The good values I found is minimum distance of 2 and max distance of 8. Now if you try again, if you zoom, now I'm blocked. And if I zoom out, I'm blocked here. So it's always a good distance. Now let's say we want to animate our camera when we are on the head to this position. We need to get the position value and the target value. To add some visual controls, let's add Leva library. Once done, here on dev, and let's go back to it. We use the hook from Leva use controls. Inside we will have get camera position. We want this option in our debug UI to be a button. And what it will do is console log the camera position, and we will destructurate what we get from controls.current.getPosition to have it in the right format. We do the same for get camera target. We just log the value we have. Be sure to import the button from Leva and also use controls. So now you move the camera where you want it to be placed for the head. Let's say here, get camera position, you have the value, and get camera target, you have the value. We could use those values directly in the code, but we made something generic with the database. Let's continue like this. Let's open Pocketbase and create a new collection. We name camera placements. We will simply need a name, then a JSON containing the position. So it will be our JavaScript array that we just logged. And we do the same for the target. Target, we create it. And don't forget, because we will need data from it, to go to API rules and to unlock the list and view rule. So we'll be able to expand it. Then create your different camera positions. We have the head, copy what you logged here. The array is in the right format. Define it for the position and the target. Then create and repeat the process for every part. Let's say we want to make the hair. You put your camera at a different position to have a nice view of the hair wherever you find it's good. You click on both and you paste your values. Okay, create. I will add another one for the bottom part. Create. And last one for the top. Here it is. And then create. Now we have those 4 camera positions. We go to our groups and we will add the possibility to assign a camera placement to a group. So we edit our collection. We add a new field. It will be a relation, camera placement. The link is with camera placements and it's single. One group has one camera placement. Then save changes and let's bind the value. So for the head, the camera placement will be the head 1. For the hair, it will be the hair. For the face, it will be the same than the head. So you can create different ones if you want, but me, I will just stick with those 4 and let me speedrun the process. And for the last one, accessories, because it can be anywhere, we just leave it to empty to the default camera value. So now we need to get the data of our camera placement. We go to the store where we fetch our categories. Currently, we only expand the color palette. So to add another field to expand, we add comma and camera placement. Now we have everything to do our logic in the camera manager. So we can add a use effect when the current category change. So current category, and we need to have access to it with our configurator store. So the logic is as follows. If we have a camera placement in our current category, then we will call setLookAt with the position, the target, and then we set true to say to make a transition to that new position and target. If we don't, we will want to go to a default position. Let's declare those camera default positions. We need the default camera position, this one, and the default target, which will be at 0. Before forgetting, we'll use this, where we set up our canvas to have the right position used here. Now we can do the opposite. So if we don't have one, instead of using the one from our category, we'll be using the default position and the default target. Now if we try it directly, it will zoom to the head. Then if we go to the hair, it moves. Now go back to the head. If I take one of the top category, you can see it zooming out and we can see the whole part. Same for the bottom. But if we go back to the face parts, you can see here it's difficult to read. Let's adjust those categories names. This is in our UI, categories.map, and let's edit the style. Instead of having dark gray when it's not selected, we will just make it brighter. And now in all conditions, it's readable. Now our experience is better. We can animate the camera, but we have one big issue is if we rotate the camera, the light in our back is too strong. The shadow on our character has a bit some issues if we look here, and globally there are some parts of the background that are bad. You see how in a project you don't know everything at the very beginning, so we adjust little by little and make it better. Let's adjust our stage. So first we can go to app and change the default background. We will just change the background to make it darker, the fog, and save. Now we can change our floor, our lights in the experience. Instead of using this backdrop, we'll be using a simple plane, so we can look at 360 without problems. Let's add that plane. We'll make it to receive shadow and we rotate it to be the floor. We add a plane geometry, a very long one, and we add a standard material with some roughness to have some light reflections on it, but not too much. We also avoid to have pure black, but very dark gray. And we can remove our backdrop. All right, it's better, but the lights are odd. For the backlights, I decided to replace them by lights not too much in the back, but a bit on the side and still in the back, with more intensity, but not pure red or pure blue. I'm using red, but with some other colors, and same for the other side with a high intensity still, but you can see it's blue, but with a bit of other colors to make it less pure blue. Then we can remove red and blue, and this is what we get. You can see the night light reflections on the floor, and it's looking already way better. And in the back, it's not too strong on our avatar. Of course, adjust to what you like. I've also seen that for the shadows, we can enhance it a bit by setting the focus to 0.5. That avoid to have the shadow on the head from the hair. Okay, now we can remove this box. We don't need it anymore. So simply go to the app, add leva manually, and add hidden. So now it's not visible anymore. And if you need it, just remove the hidden props. Now what we will try to achieve is to be able to take good looking pictures of our avatar. Let's say I'm putting my camera like this. I want to pose my character in a new animation and take a picture. First, we need to be able to change the pose of our avatar in the builder. To find pose, we will still continue to use Mixamo. You can either use animations, but if you want to take a picture, it's better to have still pose. So you can search for pose, and there are a lot of pose available. Find the ones you like. Let's say male standing pose. You can adjust the character arm space. Often for this one, because it has a huge belly and short arms, it's good to put something close to 80. And once you are happy with the pose, download it. You don't need the skin, and download. Then you can find another pose. You can see here the arm is a bit too much in the body, so just increase the arm space. Looking good would be a lovely picture. You download the pose, And then let me show you how you combine them into one single file using Blender. So first of all, you can drag and drop the pose you downloaded, import FBX. Here you have one pose. You can go expand the zone below, go into Dope Sheets and Action Editor. You name it the way you want, let's say Buzzy, and then you push it down. Then you drag and drop the second pose, and you have two armatures. You only need one because you just want the animation data. So you can delete the new armature, but still here it didn't delete the animation. So you can select your existing armature. On it, you apply the new animation data. You name it like chill pose, push it down, and to verify you have everything, or if you need to remove or rename them, go to nonlinear animation. Here you have the list. This is what will be included in the file we will export. You can verify it on the top right, animation, NLA tracks, and these are your animations. Currently, we are also using idle.fbx directly with the fbx file. We can add it to the same file, so it's more optimized. We only load one animation file. So same process, delete the new armature, go back to your main one, go to Dope Sheet, Action Editor, take the animation data, name it this time to idle, push it down, add as many animations as you want, as many poses. Once you are happy, you can save it and export the file into GLB, and let's add it to models, and we can name it poses.glb. Normally you don't have anything to change, just be sure animation is checked, and to enable compression to reduce the file size, then export GLTF. Now we have poses.glb here. We could get rid of idle.fbx, and inside our avatar we can simply replace use FBX with use GLTF and use poses.glb. Before adding the logic to change the animation, let's use idle to be sure we didn't break everything. Our avatar is still in idle animation, that's working. Now let's add the logic to change the pose. So again, the main logic is always in our global store. We'll add an object containing all the different poses. We could have make it in database, but I wanted to have one single file, and it's easier to do it here. But you know the logic to add new things to database. We create a new object named photo pose, and the key is how we will name it in the UI, and the value is the name of the animation in our file. Here I'm using the same values, but you could use different ones. Now in our store, we will have a new variable named the pose, and by default, it will be the idle one. And then a set pose method to be able to change it. Before doing the UI part, we can change the default animation to ninja, head back to our avatar component, and let's do the logic. So when the pose change, const pose is equal to use configurator store of the pose. And here to play the animation, we will change it when the pose change. So we'll play the pose. To have a nice transition, we'll add a fade in with the duration you want. It's in seconds. And we will return a fade out of the previous one. Now we can't change the pose yet, but you can see that it switched to ninja pose. Let's add into our UI a way to change the pose. But first we will add a new mode. So if we are in editor mode or in photo booth mode, we create an object named UI modes with photo and customize. We are doing this because we are not using TypeScript, so we want to be sure that when we compare things, it's with the right values. Now, inside our store, we'll set the mode by default to customize. And when we change the mode, we will set the new mode, but we will also, if we are going back to customize, set the pose to be idle. And we can also reset the main pose to be idle. Now let's add the logic into our UI. We can create a pose box here, like the assets box. We create our pose box. We get access to the current pose and the set pose method when we want to change. So we return a box, the same one than the asset box to keep the UI simple. And we loop through all the different poses. And we create a button to be able to change the pose. So on click, we set the pose to the new one. And we just display the name of the pose. Now we need to use pose box. So next to where we use assets box, we need to render it conditionally. So here we do it only if we are in customize mode. And then if we are in photo mode, we render the pose box. And below our boxes, we will add two buttons to be able to change if we are in customize mode. So we'll set the mode to customize. We display customize avatar inside. A small line to act as a separator between the two buttons. And the second button for the photo mode to set it to photo booth mode. We need to access those variables in this component. We need the current mode and the set mode function. Let's try it. We switch to photo booth and now we can see all our different poses and we are able to change, but the camera is too close because we were on the head. Let's head to the camera manager. We need to know in which mode we are. So mode. And here we will change the camera. Also, if the mode change, we want to be sure that mode is equal to UI modes of customize. If it's photo booth, we want the default position. Let's try it. We switch to photo booth. Now we can change the pose, go back to customize avatar, and the camera is going back to the right place. Now we are able to generate good-looking avatars and to take the pose for pictures. We want to add a button to take the picture, a screenshot of it. Let's add a control to do it. In the UI, we have the randomize button, the download button, but between, we will add a screenshot button. We can use hero icons again, use the camera one, then we simply go to randomize button. We will entirely duplicate it. For a bigger project, I would create components for button, but here it's okay. Screenshot button, we'll have later a screenshot function in our store. On-click screenshot and simply replace the SVG with the camera. All right, we have the camera on top. You don't want to click on it because it will crash. Instead, let's prepare the screenshot. So in our store, like we did for download, we do exactly the same with screenshot. So it's a method that is set by one component in our 3D experience and the setter. Now let's go to experience and we will add the definition to this function here. First, we want to get access to set screenshot to be able to define it. And we need to have access to GL, the renderer, with use 3. In a use effect, when GL change, we will create our screenshot function. First, we will create a new canvas because we want to add other things to our 3D canvas, to add our logo somewhere on the screenshot generated, better for branding. So we have this new canvas, but we set it with the same dimension that our existing canvas. So on GL, DOM element, it is the main canvas we are using for rendering our 3D scene. We assign it the same width and height, and then we get access to our canvas context with getContextToD. If we can't get one, it will fail and we return. Then we draw to our new canvas the content of the 3D canvas we already have. 0, 0 is where we start on the x-axis and y-axis. So as it is an exact copy with the same dimension, we start on the top left. Then we want to add our image on top of the screenshot. So we create a new image. The path to it is our logo we already have in our UI. We set cross origin to anonymous, otherwise it won't work. And on load, we will draw it on the canvas. So we need to assign it a width and a height. So 765 and 370 are the real dimension of my logo, and I'm dividing it by a number to scale it. Then to position it, we simply define X and Y variable using the width of the logo, some padding values, and the size of our canvas. Once you have it, you have everything to draw it inside your new canvas. So you draw the logo at the position X and Y, and with the dimension of the logo. Now you have your canvas ready. You just need to do the methods to download the canvas content into a PNG file. This is what you find on Stack Overflow. I don't know this by heart. And then once your screenshot method is ready, you assign it to the store. Don't forget to do all the required imports. Use effect, use Three, use configurator store. Let's try to have a screenshot of our avatar, but it's giving us a full black image with our logo in the bottom right. Yes, without the camera, you will see it. This is happening because when the screenshot is taken, the canvas is cleared. So what we need to do to avoid this is go to app when we set up our canvas. On the rendering properties, set preserve drawing buffer to true. Then generate a good looking avatar, go to photo booth mode, choose the right animation, right position, and take a screenshot. And it's a fail because I didn't reload. So let's reload and let's do it again. Randomize. We still have a very good avatar, photo booth, ninja pose, and screenshot. The screenshot is now way bigger, so I'm more confident. And here it is, your lovely avatar. Thank you for watching. Our 3D avatar builder is looking more and more professional. In the next video, we'll add post-processing effects, enhance the loading experience, and do some more polish to make it perfect. To continue the journey with me and build your own 3D avatar configurator, don't forget to subscribe and hit the bell button to be notified when the next part is released. See you in the next video.